Hello students, today I will discuss bias, which is also very important in biostatistics. Bias can be of different types. First of all, I'll discuss selection bias, and in selection bias we can have sample bias. Sample bias means that if our sample size is not representative of our whole population, that means that sample size is smaller, then this can be a type of selection bias. Then volunteer bias, it means that most of the people, they do not volunteer to get themselves enrolled in the studies. Again, if most of people, they do not get volunteer to get enrolled in the study, our sample cannot be representative of whole population. And then loss of follow-up, uh, they get enrolled, but after some time they do not return. So all these three are examples of selection bias. Then after that we have got procedure bias. Usually if a disease has got gold standard test, for example, for pulmonary embolism, gold standard test is CT pulmonary angiography. But most of our consultants, they are reluctant to do these tests because they think that this test is difficult to perform and it has got its own hazards, rather than they go for the simpler test which are not gold standard tests. So this is procedural bias. Or it can be possible that gold standard test is invasive and they are reluctant to perform that invasive test. Then expectation bias. Sometimes the researchers who are doing a study, they expect a certain outcome of the study. For example, if they are studying smokers and they want to see, or they know already by their knowledge that smoking, it increases the risk of CA lung. So it can affect the outcome of their study. So it is basically their expectation that most of smokers, they should develop CA lung. So this is expectation bias. Hawthorne's effect is basically bias on Hawthorne effect is the same sort of bias, but it is on the end of the patients who are participating in the study. For example, if participants, they know that spicy things, it is associated with more heartburns, it might affect their answers, or it might affect the outcome of the study. It can bias their thoughts that since they have eaten spicy thing, so they are having heartburns. Then recall bias means that the patients who are having disease, they would more deeply think that whether they were exposed to the particular risk factor which was associated with their disease. For example, a patient of CA lung will think more deeply that whether he was exposed to asbestos as compared to the person who is not having CA lung. So let me give you another example of recall bias. Those patients who have got leukemia or lymphoma, they will think more deeply that whether they were exposed to any radiations or any other risk factor rather than those people who do not have leukemia. So this is an example of recall bias. So late look bias is basically that if we are studying a disease which is very fatal, and most of the people with the disease, they have died, and we have only those people who have got early stage of that disease, it might give us an impression that disease is not very serious or it is milder. Then lead time bias means that if we are actually studying a disease that can be picked by two tests, but one test is more sensitive and it picks up disease earlier, while the other test, it does not pick up the disease earlier. This can give us an impression that perhaps survival of the disease is more, because the test which has picked the disease earlier, those people, they will survive, it looks like that they will survive more as compared to the test which picked the disease later. Then publication bias is that when a researcher compares his or her studies with international studies, he tries to ignore or overlook those publications that have negative results or that are done on smaller scale. Then after that, what is absolute risk reduction? Absolute risk reduction is calculated by subtracting experimental event rate minus control event rate. And number needed to treat is 1 divided by absolute risk reduction. Number needed to treat means, basically, literally speaking, it means that how many people they need to be treated to minimize one adverse outcome. For example, if we are treating stroke patients with aspirin, so we need to know that how many people they need to be treated with aspirin to reduce one adverse event of stroke. Then another important topic is linear regression, which actually shows impact of one variable on the other. We know that FEV1 is directly related to height. So if height of an individual is 5 feet 4 inches, we can predict that what will be his FEV1 or what should be his ideal FEV1. So was the example of linear regression. Then linear correlation. For example, if we see a class in which students who took higher grade, they study more hours. So, just by seeing the grades of the student, we can predict that this student must have read for more hours. Then after that is funnel plot. Funnel plot is to see publication bias. If funnel plot is symmetrical inverted, it means publication bias does not exist. If it is asymmetrical, it means publication bias does exist. Where on vertical axis we take the study size, while on horizontal axis we take the data or result.